Welcome to SQL Bits 2020 and to my session on Azure Functions in Cloud-based ETL processes. I'm very happy to be here today and to get the possibility to show you some of the stuff that I am working on. The image that I've pulled up here is an image that Andre Essing of Microsoft did when he visited our local past chapter. And I'm sure many of you will have already seen a very similar image when they talk about cloud-based data warehouse solutions. When you're using cloud technologies, one of the hardest things is that there's usually a huge set of possibilities to solve certain problems. And my goal is to give you an idea of a certain set of technologies that can be useful for certain aspects of such an architecture. And the technology that I would like to talk about today is, of course, as in the title, Azure Functions. And I'll try to give you an overview of what Azure Functions can do for you in such a process. But before we go into all the nitty-gritty details of what Azure Functions are and what they can do for you, let me first welcome you personally to my session on Azure Functions here. And let me first pull up a slide to introduce myself. My name is Benjamin Kettner. Most people call me Ben. I did my PhD in applied mathematics 8 years ago. However, please don't run away scared, because even though I did a PhD in mathematics, I learned to express most of my daily communication without the excessive use of formulas. So you might call me a domesticated mathematician if such a thing exists. 5 years ago, I co-founded MLPA Consulting. We're a consultancy that offers IoT and cloud solutions from end to end. Meaning that what I'm going to talk to you about today is stuff that I work with on a daily basis. So this is really a talk that's inspired by my daily work and not by reading a white paper. And this is very important to me. This summer, I was for the first time awarded an MVP award, which makes me incredibly proud. And it still feels really strange to say that, to be honest. What are Azure Functions? I believe strongly that if you want to work with a technology, if you really want to apply a technology, it is of vital importance that you understand at least a certain concept of the basis of this technology. So I'll try to introduce you to Azure Functions before giving you details about where I like to employ them in certain processes. So first thing, Azure Functions are event-driven. What does that mean? That means that a certain event can cause or will cause an Azure function to execute some code. This is really important because this is one of the core concepts of Azure Functions, that they're event-driven. When I say they allow for many triggers, what I mean is there's many different events that can cause an Azure function to trigger and to run certain code, which is also important because it means that not only can you trigger an Azure function by doing a REST call on a web API, for example, but you can trigger it, for example, by receiving a message on your IoT hub. So this is what is really one of the basic concepts that you need to understand and that you need to remind yourself of, that the nature of Azure Functions is usually that they're driven by events. The compute underneath happens on demand. I'll talk about that a little bit later. And you can write Azure Functions in multiple languages. You can use Python, you can use certain... I'm not sure about all languages, but there's a lot of languages that you can use for Azure Functions. However, all code examples that I will show you later on will be in C# in .NET Core. Azure Functions are serverless, meaning that there's no infrastructure for you. And that means that Azure Functions can handle all the scaling and scalability for you. But still, Azure Functions are able, and that's really important, to handle state if you want them to. The keyword here is durable functions. A durable function is a function that manages a state of some sort. We'll talk a little bit about durable functions and states later on, but this is one of the key concepts that's also important for certain processes. What I mean when I say Azure Functions are serverless. Serverless computing, for me, and this is my personal view in this slide, takes the platform as a service idea to the next level. Because you don't have to deal with management, of course, because you're using a platform service, or scalability or provisioning of compute power. Meaning, if you have a web app, and that runs on an app service plan in Azure, what usually happens is you select that app service plan to provide certain scalability, to have a certain number of cores running, to have a certain number of instances running, to have a certain size of instances running. You do not have to do that with Azure Functions. Of course, you can deploy an Azure function to an app service plan and deal with that yourself, but you don't have to. You can run an Azure function on a consumption plan, meaning that you do not have the possibility even to deal with its scalability or the underlying compute power. All of this is done for you, and what you pay for is only the consumption. So if you have an Azure function running on a consumption plan, and you don't call that for a month, then it won't cost you a thing. Not a single cent. Because you only pay for the consumption once you're running on a consumption plan, which is quite a nice feature, I believe. Let's now head over and do some demoing. What I've done now is I've pulled up PowerShell. And I've done so because I believe that it's best practice and everybody should make a habit out of creating Azure resources from some form of code, because this enables you to do stuff like store your infrastructure, enable you to recreate it when needed. And I think that's a huge benefit lies in doing so, and I believe that we should do so. So I've pulled up PowerShell, and now let's in PowerShell first, if you have the extensions installed, of course, but doing that would maybe be a bit excessive for this session. I'll just type func, and func, of course, as in function, not as in Bootsy Collins. So now I type func, and what happens is I get offered with a certain range of commands of help that I can use. So let's have a look. First thing that's offered to me is quite interesting for me, is context. Context is like, for example, sets of commands. So there's this set of commands that's called Azure that is used to log into Azure and manage your function resources in Azure. Makes sense. Next set of commands is durable, is commands connected to using durable functions. Those are the functions, I remind you, we touched this briefly before, that manage their own state, that have a state and that are able to handle that state. So this is a set of commands for working with durable functions. Next, we get extensions for installing extensions. We get function for creating and running functions locally, which is useful during development and debugging. We get host if we want to modify the behavior of our local function host. And this is really interesting. We get Kubernetes. And Kubernetes are commands to use when working with Kubernetes and Azure Functions. And I think this is really important because often I get asked by customers if we use something proprietary like Azure Functions, is there any migration path if we decide to switch to another solution like Kubernetes where we cannot use platform services? And apparently here the answer is yes. And there's settings and templates. There's also a few actions that are offered. Start if I want to launch a runtime host and work with that runtime host. New if I want to create a new Azure function. Init if I want to create a new function app. And that also initializes a Git repository, which is quite cool, I think, that I get the source control as an additional without any extra work. And I have the logs action, which enables me to get logs also from functions hosted in Azure, which is quite useful. But let's first start by using functions init. So func init. Let's initialize an Azure function. And when I do that, I am first asked, which runtime I would like for my Azure function. Of course, I will select .NET because .NET is the language that I'm most familiar with. But as you've seen, you could have also selected Python if you want to use code that's available primarily in Python. Or you can use Node if you feel like using Node. So you have a choice here of languages that you can use to create an Azure function. Now, once this has happened, what I have is a project that can contain the code for Azure Functions. I do not have a function as such. What I've created in init is a new function app, so basically the container, but not the function itself. So we have to differentiate between creating a function app, which is the container that hosts a function, and the function itself. Now, what we need to do next is we need to create a new function. So what we do, before we chose func init, and now we want to create a new function that we want to have in our app. What was created now is basically just the CS project file. So a C# project containing certain host and local settings that will help us work with the function. So now let's create a new function. So func new. And we have to give this function a name. We'll call it demo triggered. We'll have a look at that in a moment. So what does this function do? This is a function that we'll create. And again, we have a template. We can select the template that we want. We can say, okay, we want to have a queue trigger, which means if we have a storage account and a storage queue, and an item is added to that storage queue, then our function is triggered and the code in that function runs. We have an HTTP trigger, meaning if I get a GET or a POST request, depending on how you implement your function will be triggered. We have a blob trigger, meaning that if a file is added to a blob, or if a file is removed from a blob, your function is triggered. We have a timer trigger, meaning you can trigger your function by a timer. You can set a time when your function should trigger. You have like a durable functions orchestration. We'll talk about that later in a bit more detail. You have a send grid trigger. You have an event hub trigger, and that means if you can trigger your function if an event is created on an event hub. You can subscribe to an event hub. Same goes for service bus, queues, or topics. Event grid, Cosmos DB. You can trigger a function when a new record is created in Cosmos DB. Or IoT trigger. So you have quite a range of triggers that you can use to trigger the code in your function. So let's first start with an HTTP trigger. And now we'll have to name our function. Function name, demo trigger. Now we've given our function name, and what will happen now is a C# file will be created. And we'll have a look at that C# file in a moment. Okay, so once our function is created, what we can do next is we can have a look at the directory. And what we'll see here is an extra file that wasn't there before, and that is, of course, the source code file for our function that we call demo triggered. So let's have a look at that source code file by opening it up in Visual Studio Code. What we can see here is we have a class, and in that class there is a function, and you can see that the function name is given here in this attribute. So we can change the function name by changing this attribute. And what this function does, it says, okay, I have an HTTP trigger. I'll listen to GET and POST requests, and I don't have a specific route. I can give a routing and add a specific route here, but we'll not touch that at the moment. And what I'm handed is the HTTP request from when I'm called, and a logger that I can use to log information, or errors. And what this does first is, this is this template that we were using. It logs the information that once an HTTP code triggers it, once it's triggered by an HTTP trigger, it says, okay, I'm processing a request. Then it reads the name from the request, tries to read the name from the query. It tries to read the body and deserialize the body. And it says, okay, I'll either use the name that is given on the URL, on the query parameter, or if that's not present, I'll use a name given in the post body. And then I'll return the name. Okay, now that we've had a look at the function code and we've understood what's happening and how the HTTP trigger is supposed to work, let's test drive the whole thing and run our function locally. For that, we go to the directory where our function was located. And all we have to do is we just type func start. And what that does is that starts our local function host and looks in the current directory, looks whether there is a function here, builds that function, and runs that function within our function host. So that's what's happening in the background now. The function host is starting. It's starting the build. You can see the build engine running. Now the build of my code is running. It's restoring the project. They're all up to date, of course, because I've just worked with that function. It finds the DLL that should be used for my demo, and it starts the host. And what the host does, the host outputs me quite a lot of information. And what will happen here is we'll have the logger that we saw will be detached to our command line. So everything that is logged in our execution will be output to the command line. So let's now go here and test drive our function. If we want to test drive our function, then we should click in the right window. You would think that doing a demo that's not live but pre-recorded makes it easier not to mess up these things, but believe me, it's not. So we can go here, we can copy the URL of the function, and now we can run this in different ways. We could use Postman, for example, to post a request to that host. We could use PowerShell, but what we're going to do is we're going to use a browser, a simple browser, a web browser. We'll just paste the URL into our code, into our browser window. And what should happen now is we've not passed a name either in the URL nor in the body. So what we should see is a response asking us to pass a name in the query string or in the request body. So this shows us that our function apparently is running. And what we see here is we saw executing HTTP request, and we can see that a C# HTTP trigger was processed, which was the log message that we had in there. And we get some additional information. Now, let's go back here and pass a name. So let's say we pass my name because I'm such a nice guy. What happens now is we get the output string hello Ben. That's nice. Hello function. I'm happy you're here. So now we've run our first function successfully. We can go the next step by deploying that function to the cloud, which is exactly what we'll do in a moment. So we'll go ahead and deploy this not very intricate and not very exciting function to the cloud. And we will do that again using PowerShell, of course. So if we want to deploy that to the cloud, whoopsie, why is there a sign-in window popping up? Okay, now we can see here again that our function was triggered for a second time. And we see the second trigger down here. So we see logs of both executions. And this is important because I told you before that it is a good idea to have application insights running. And it actually is, because you can log all the information that you need, all the triggers, all the bodies, all the queue messages, everything to your logger, send them to your logger, and query them from App Insights. And this is really, really helpful when you have functions running in a productive environment. So please do this and remember that this is really vital if you have a function running in a production environment. Okay. So the next thing we'll do is to deploy the entire thing. Now what we've done now is I've pulled back up the Azure portal. And now let's have a look at what was created while we were demoing our function locally. So strangely enough, this might seem surprising, a app service plan was created. But we said we didn't want a function on an app service plan. So what does that mean? Let's just click it and find out. And if we open that app service plan, what we will notice is that this app service plan doesn't have scale up or scale out functionality. Those are not available to us because this is a consumption plan. We cannot scale up or scale out because Azure decides for us the size and the number of hosts that we need to run our queries. So this is all fine. We have this function plan mostly for reasons of access control and logging and triggering events. But for the moment, we won't need that. And our function was created together with the application insights and the storage account. Now, if you have a durable function can do several things. A durable function has the possibility to handle its own state, and for that, it will create entries in a table storage in your storage account. So that's why, for example, we need the storage account here. Okay, so our function was called SQL bits functions demo. So far, if we click that function app, then in this function app, of course, since we haven't deployed anything here, we will see no functions. So let's check that and put that to the test. And you will see if you go to the functions blade of your menu that there are no functions here. And that's what we want to change now. So let's go back to our PowerShell, and in our PowerShell, stop the local execution. And now we can say function, and the next thing is the context that we're working in is now Azure. And what we want to do is we want to work with the function app. And what we want to do in that function app is we want to publish. And what we want to publish, well, hang on, I've lost my windows here. So the next thing we want to do, if we do so, we can always append help here and get some helpful output. And we can, for example, list functions. We can fetch app settings if we want to check the app settings, or we can publish. So we will choose publish. Okay. So we will choose publish. And we need to enter a name of our function app. And as we remember, our function app was called SQL bits functions demo. So let's enter that here. SQL bits functions demo. And if we do so, what will happen is, again, a build will be triggered. And what will happen next is our code will be deployed to our function host there. So let's see how this happens. Now we run our functions demo. We publish our functions demo. It's happening now. And once this has happened, we'll have our function available in the cloud. After our function was deployed, again, it was first built in a release version was built. After that was done, publishing info was collected, and then the files were uploaded, and then our triggers were synchronized, meaning that the function host in the cloud was made aware that there is now a function running with an HTTP trigger. And the next bit of information that we get is an Invoke URL, which is quite helpful because this is the URL that we need to use if we want to invoke our function. So I'll copy that, and we'll come back to that in a moment. Now let's switch to the cloud again, to our host. And let's refresh here and make sure that our function was deployed. And if we refresh here, now we see the function with the HTTP trigger. And now let's go on and trigger that function. If we want to trigger that function, we'll just paste the URL here. And again, we'll see the message that we're already aware of. So we need to pass a name in the query string or in the body. And we'll do that. And again, I want to greet myself because I'm a bit selfish today. And if I do that, I'm greeted again by that function. So our function is executed as we expect. Now let's have a quick look at monitoring and debugging functions that are running in the cloud. We'll be really brief here because this will be another session in itself. What I can do if I want to monitor, I have this monitor blade in my portal. And if I go here, then with a certain delay, that's usually depending on how much your function is utilized, up to 5 minutes, you can see the invocations, the log of the invocations, and you can go and see the logs of your functions if you have application insights enabled. And now you can see the log stream. You can connect to the host and see the log stream just like you saw before in your PowerShell. And since we have enabled application insights, we can do even more. We can monitor the execution of our function in real time. And this is quite a nice feature. We have the real-time monitoring here. And now let's trigger our function again. We've triggered our function. And if we go back to this tab, we see in the log, we see the execution. And we should see the execute. Okay, we can see that it was executed in the log stream. And now this is a bit annoying, but you can see your request. The one incoming request that you see here was the request that we made. And all of this, you can see down here, you have a server running that we never provisioned because this is the serverless execution that we were talking about. I'll close that down so it stops scrolling there every time. And this is quite nice. So application insights here gives you a good way of monitoring how your function is running and what your function is doing. What we'll do now is we'll come to, now that we've learned about functions and how they work and what they are, we'll go back and we'll have some discussions about how to use these functions, how to use this technology in cloud-based data warehousing and cloud-based overall scenarios where I like to use them. And I'll give you some concepts, some patterns where I think they're particularly useful. So we'll have a look at that and switch back to PowerPoint for that. So back to our PowerPoint from our quick demo. Let's move forward a bit. And first I would like to send you a word of warning. Everything that I talk now is purely fictitious, and any coincidence with any real person living or dead or project is purely coincidental. So please do not be alarmed if some things sound familiar. Okay, what I'm going to do now is I'll start drawing a little bit to explain some of the concepts that I have. Okay, let's say we have this bloke, and let's say, to make this more realistic demo, that this is a nice bloke, nicest bloke you've ever met, with this really long and impressive and huge beard. Okay, and let's call this guy, I don't know, let's call him Bob. Bob's your uncle. So this is Bob. Okay, meet Bob. He's a really nice guy with an impressive beard. Nicest guy you've ever met. Bob says hi using our brilliant Azure function. Okay, now Bob has some web API. Okay, Bob has some web page that provides some web API. Okay, since Bob is a music fan and Bob likes cycling, let's say Bob has a web API that gives us his playlists for his music. And let's say this API is updated once per day. So we want to load these playlists every day. We want to update in our daily load. And in our daily load, we'll use, let's say, Azure Data Factory to load those playlists into our data warehouse. Now, if we look at the data in our data warehouse, what we'll see is we'll have a playlist ID, and we'll have an artist ID, and we'll have a track ID, and we'll have an album ID. That's what our playlist will look like. Okay, so what he has in his API as well is he has an artist endpoint, okay? So these artists, again, once per day, we can go here, load all the artists that Bob has in any of his playlists, load the artist ID and the name. And he has an album endpoint. And again, once per day, we can load all the albums using the artist ID. For all the artists that he has, we can use the album ID. So we can load the album ID and load the name of the album to our data warehouse. And he has a track endpoint. And once again, once per day, we can load all the tracks for all the artists and all the albums with all the titles into our data warehouse. And then we'll have everything that Bob has in terms of music. And we can work with that. However, say Bob has lots of playlists and even more artists. Do I really need to load the entire albums and all tracks of all albums if he only uses one song for his playlist? So of course this is not the best way to go about it. If we do this, what will happen? Our Azure Data Factory pipeline will look something like this. You'll have an activity to get the playlists. After that, you'll have an activity to get the artists. And after that, you'll have an activity to get the albums. And after that, you'll have an activity to get the tracks. However, what will happen here is this will not be one activity, but this will be for each. So for each track, we'll get the artist, and for each artist, we'll get the album. And for each album, we get all the tracks. So these will all be for each activities, meaning that the runtime of our pipeline, if we have only one new track, will be to get the playlist, to get the artist, to get the album, to get the track information. So the runtime will be 4 GET requests for each track, which will take quite long. Now, if Bob didn't care about money, then that's probably what he'd do. However, if Bob is like any of my customers, he's in some way cost sensitive. And then he says, okay, having the integration runtime, which is quite an expensive resource, run throughout all these requests is not really important if there's not a process behind here that works with that data. If the only goal is to have that data in the data warehouse, then I don't need to wait for all these to complete. So what could Bob do here? What he could do is he could create an Azure function. Okay, so what will Bob do? Well, Bob would have his endpoint, his API that we already talked about, and Bob's Azure Data Factory would trigger an Azure function. Now that Azure function would call the API to get the artists, or get the playlists first. Okay? And then it would take the result and put them into a storage queue. Okay, and he would have another function here, and that function would have a queue trigger. And that function with the queue trigger would then be triggered for each playlist or for each playlist item to fetch the artist and to fetch the album and to fetch the track. Meaning that the pipeline in his Azure Data Factory would be done once it has triggered this function. The pipeline is done and can do something else. And I don't need to pay the runtime of the ADF while my function is doing work, collecting data and placing that in the data warehouse. And then we'll, of course, connect to the data warehouse and put the data there. And what we could do, once we're done, once all of this is done, what could be done? Of course, you could use an Azure function to trigger an ADF pipeline again. To trigger an ADF pipeline, that says continue processing. Continue. And that will be a pattern where you would have all these processes that were synchronously in our Azure Data Factory, asynchronously in your function and decoupled by the queue. Now, another benefit of this is, depending on how long all your requests are, you could even split this up further. You could go here and say, okay, get the first playlist, and then trigger this function again, saying get the second playlist. And then trigger this function again, saying get the third playlist. Trigger this function again, saying get the fourth playlist. So depending on the runtime of your API and the possibility of your API to scale, you would even be able to fan out, to scale out here, and have all these different get requests or fetch requests from that API. You could also do those. Asynchronously, and thereby reducing the time this function runs and having a smoother execution and speeding up the execution, because you can start fetching the next sets of data while the first set is still not completed. Of course, what you would have to do in that scenario is you would have to add a functionality to log and inform you when you're done, and to check whether there are still functions running. So you would have to add another extra logic to that function in order to enable you to do that kind of processing. But if you do that, the benefit is that you can be very flexible and very fast and very asynchronous when accessing web APIs. And this is really a benefit that helps a lot in many scenarios. For example, one scenario where I use that a lot is, for one customer, I query Jira. And the Jira API, if you've ever worked with that, is annoying. And what the Jira API does is just, okay, you can query and get a list of all the issues. And then you can iterate through each issue and query all the tasks attached to these issues. And once you have a task and you get certain information about that task, you can get further information about that task by doing another query. Okay, so getting the status of a task requires yet another query. And if you do all that in one function, you'll run into timeouts really fast. So this is not the way to go. If you do this in ADF, you can do this in ADF and have a for each, and then your pipeline will run very long, and this will cost a lot. If you do this in ADF, again, there might be there will happen scenarios where, for example, Jira, the API fails. If it's a self-hosted Jira, this is more likely to happen than if this is a hosted Jira instance. And then you'll have to retry, and you'll have to check, and you'll have to re-enter credentials, and so on and so forth. So doing all this error handling and exception handling and process handling in ADF is quite a lot of work. Whereas doing it in code is fairly easy, because it's requesting you say, if this happens, then do that. So it's if cases and queries that you need to do. So the .NET code to do that is fairly straightforward. And the ADF way to do that is possible, but it's a bit annoying, a bit tedious, and you run into exceptions every time, and you need to check this and recheck that. And so this is a scenario where this pattern is really helpful, because you say, okay, I know there's this issue, query that issue. If it doesn't work, place it back in the queue and try again later. And you can have patterns like that where you can have a number of retries. If you place it in a queue, you have a body, you can add information like, I tried this once, I tried this twice, I tried this 3 times, and you can know, okay, do I need to retry again, or what do I do? And this kind of handling is really neatly done with Azure Functions. So this is one thing that you can do with Azure Functions, where Azure Functions help your ETL process. Now, if you remember the picture that we saw on the in the very beginning of this presentation, I showed you this modern data warehouse architecture. And all of these modern data warehouse cloud architectures have one thing in common. What's in there is usually some point of streaming. So usually at some point, somebody says, okay, I have a source. Let's say it's an IoT hub. And this source streams events. And then some magic happens, and these events go to your data warehouse. Now, this some magic happens is usually where it gets tricky. And luckily, what you can do is you can have stream analytics here, and stream analytics is pretty amazing, can do a lot of stuff. But when it comes to enriching events, it gets a bit tedious to do that in stream analytics. And when it comes to calculating certain rules and evaluating certain rules to alert or stuff like that, doing all that in stream analytics requires a lot of redeploying stream analytics, worrying about stream analytics, deploying it again. So what you can do here is you can have your events trigger an Azure function instead. You've guessed it already. And what can your Azure function do? Your Azure function can do some enrichment. Okay, and then load your data, for example, to the data warehouse, or load it to an event hub to trigger an alert. So let's go back to our example with Bob. Okay, our bearded friend Bob. Okay, our bearded friend Bob listens to some music on his headphones, expertly drawn by me. Okay, and now our bearded friend Bob has this brilliant idea to stream the music that he listens to an IoT hub. So the music that he listens to is streamed to an IoT hub, information about the song, a song ID, for example. So what you'll do here, you don't want to stream the entire data set of the song. So what you'll do here is you'll stream a track ID. Okay? So you'll stream an ID of the song. And now what you want to happen is you want this enriched and say, okay, he's not, you don't want to know which playlist he's listening to, but let's say you want to know which song, which artist, which album is this. So doing this in Stream Analytics is already a lot of work because the data set of your songs, artists, and albums can be quite huge. What you can do in your Azure function, and that's now the first time where we'll see durable functions come to play. You get the event with a track ID. Okay? Now you have a track ID. And what you can do, you look using your durable entity, you look into your local table storage, to the table storage associated with your function. You do that by implementing a durable entity. And all of this is done for you if you say check if an entity exists. This is what happens under the hood. So you look into your table and say, does the song that I want already exist? Do I have information about the song? If it exists, I get the information back. If not, I get back an information that tells me I don't know about the entity that you're talking about. And if I don't know about the entity I'm talking about, I can query the data warehouse and get information about the result and store it back into my table. Now, why would I do that? Let's say Bob is a real music nerd and listens to 10,000 songs a day. Okay? And probably grindcore, because to get 10,000 songs into a day, the songs need to be very short. So let's say Bob is a grindcore fan and listens to 10,000 20-second grindcore songs per day. And so we have 10,000 events coming here. And those 10,000 events, if I didn't implement it the way I just explained to you, would mean that 10,000 times we queried the data warehouse to get information about what track is this, what album is this, what artist is this, and then write back this information into the data warehouse enriched with the event. Now, if I don't want to do it that way, then I put them into the table. And let's say those 10,000 songs that he listens to, out of these 10,000 songs, there's 2,000 unique. And now some people might say there's no unique grindcore song, all grindcore songs sound alike. Yeah, I might agree over a beer, but that's not the point here. Let's say there's 2,000 unique IDs that he's sending, meaning that really what he has to do is he has to query the database only 2,000 times, and the other 8,000 times he can get the answer already from his durable entity. And he can get the information from his durable entity to enrich his event and write that event to the data warehouse, meaning that he's significantly reduced the number of queries he's running on his data warehouse by using this pattern. And that means that he has the possibility to enrich the events. And now let's imagine a scenario where you're not writing directly to a data warehouse, but where you're in a service architecture and you write to different services. And he has the information to provide enriched information to different services by using this pattern without overly putting overly stress on his data warehouse. So this is a scenario where you can be very successful in that way by delivering events to your data warehouse. I have a scenario with a customer where I'm doing just the pattern I described here. And I do it on my endpoint. It's not an IoT app, it's HTTP triggers. And my HTTP trigger is triggered 20 to 40 times per second. And these 20 to 40 times per second, I get information about the user. And I want to know what opt-ins has the user selected on a certain web page. Those opt-ins are in my data warehouse and are updated once a day. So if I queried the opt-in for one user once that day, I do not need to query it again because it will not change. With the songs, it's even a higher ratio, because if once a song is published, the artist usually doesn't change. And so in my scenario with my customer, where I have these 20 to 40 calls to my endpoint per second, I enrich that data with data from the data warehouse. I deliver that data to other destinations that enrich data to work with that data. I write that back to third-party systems, to production systems. And I store it in my data warehouse as an event, so I can query it and have like activity reports. And I do all of this with one Azure function that applies this durable functions pattern. And this is a really strong scenario where Azure Functions scale really well and do stuff that you could, of course, do with other technologies. As I said in the beginning of this talk, there's always more than one way to achieve what you want in the cloud. But these are scenarios where Azure Functions work quite well. Which brings me to my final slide, to my wrap-up. I find Azure Functions useful in many scenarios. The availability of many triggers makes them really flexible helpers. To have like one set of code, one set of thinking, where you have the possibility to trigger an HTTP request, trigger by placing an item in the queue, trigger by having a message on an IoT hub. The possibilities you have here are really great, and you can do a lot of different implementations. The patterns I showed you were queries for nested requests, nested REST queries that we discussed, asynchronous processing if you don't want your Azure Data Factory to be running the entire time, IoT hub triggers if you want to enrich certain events, and durable functions to reduce database calls during your processing. And with that, I reached the end of my discussions, of my demos, and I really hope you enjoyed it. It was really great for me doing the first pre-recorded session I ever did. Now I can say I hope that there were plenty of questions in the chat, and I hope that I was able to answer them all. And I wish you all a very great rest of the event. Thank you very much for listening in.